Hello guys, and welcome to this new video in the game engine series. Hope you guys are doing good. Hope you guys are healthy. So in this video we're going to be talking about particle engine. So we're going to be kind of talk generally about what are particles and what is a particle engine, how to generate them in our game, because this concept mostly come when we talk about game dev and stuff like that. So, and it's really important because it kind of give like life into your scene, into your game, so that you have things moving around that you don't have control on, and they should be random. So you can see right here we have this dust coming out of the screen right here, and just kind of give life to the scene, and that's really important. And I'm gonna be showing you later how we can also generate lightning and raining and stuff like that. So that's what we're gonna be talking about in this video. Now, this is probably your first time watching this. Just want to let you know that there is a link to the playlist in the description below. You guys can go and check that out. So we have been trying to build a game engine in C++ using the SDL library, and we have been doing that from scratch. So I started writing the whole code, and if you want to learn to build something like this, then you probably want to go and check that out. So it's free, so you don't have to pay anything. And if you're also interested in getting the source code of this one, so you will find the link in the description below. But for that, I need to be transparent. You need to be a Patreon. For $5 a month, you'll be able to access the whole code and also impact the the things I'm going to be uploading in the future. Just want to let you know that yeah, you can still go out and support my channel for the work I'm doing if you think it deserves to be support. And also want to invite you guys to subscribe, like this video, leave a comment in the description below, and if you have any kind of question, I'm open to answer your question as long as I can. And yeah, let's get started. So as I said, we're going to be talking about particle engine. So what is a particle? A particle is like just like a random random particle. So think something like that, like I'm going to be taking an example to explain that. I didn't even check Wikipedia before doing this, so I could have simply give you a definition from Wikipedia, but I didn't want to do that. I kind of want to give you something that is more personal, something that I understood about particle. The particle is just like a singleton, or like a single, I would say, object, like rain drops, for example, or a dust, a dust particle. And you want to kind of have this thing in your game because you want to be able to generate things that are going to be randomly created with different speed and different position, so that you will have different thing going on. Like here, for example, I can generate snow. This is not the the normal state to put snow on the screen, because we have the sun right there and everything is lightning. But just want to let you see here, for example, we have snow. We can also have rain. So we can make it rain, as you can see right here. So you see, each water drop right here is a particle, and each one of these particles is generated randomly with a different speed, different position, and the one who actually makes sure that all these particles get generated is the particle engine. So to be able to have like a particle in your game, you need to have basically two classes. The first class is going to be the particle itself. So this little water drop you want to have on the screen, and you want to have like a manager, someone who is going to be making sure that the particle live as long as is giving to it to to be alive, something like that. Because if you don't make sure that your particles when get to die, you will fill your memory, and your program will get stuck. That's why it's important to have a manager who has like an eyes on all these particles. We actually have more. You can see right here we have a lot of particles, but we have a maximum number that we never go above. So like for example, for the rain, I think we're coming to the code in a couple of seconds. For the rain, I think we have something like 800 particles. That's the maximum number that we can generate right now. But as you can see right here, particle has been falling since I started this, and they never ends, even though we only have 800. The thing is, I have some condition, like whenever a particle gets outside of the screen, it just get destroyed, you know, outside of the screen in the four sizes. So the left side, the right side, bottom and up, and all that kind of stuff. I kind of generate all these particles just up here in the position 0, and they just start falling. I just use my function to move them. And you know, they also have like a lifetime, since they are generated with different lifetime. I think for the rain right now, the lifetime is between 500 milliseconds and 2 seconds. So then a random number is going to be generated between that range, and it's going to be creating things like this, and you'll see the result happening on the screen. So that's basically what a particle and a particle engine, and the particle engine is just this concept, you know, the concept of, you know, creating all this together and, you know, embed that into your game so that you can generate nice stuff with that. Now let's go and talk about code a little bit, because this is all theoretical stuff and we don't kind of get more about that right now. So now, as I said, we basically need two classes. The first one is going to be particle. As I said, we have this class called particle, and a particle has like some basic information that are important for almost all particle. You need to have like a position, offset, x and y axis. This is in the case of a two-dimensional game. If you had like a three-dimensional game, you will have, you know, that is the third dimension for that. And in our case, we have like the x and the y axis. We also need like a speed, you know, how does it move in the x and on the y axis. And one component which is really important for a particle is the lifetime. How long does this particle need to be alive? Because you want to make sure he's alive as long as you give him to be alive, because you don't want to fill your computer with 1,000 particles that are not going to be destroyed, because those are objects, and you know, objects are taking memory every time. If I open my task manager and let you see how many memory this program is using right now, let me run this, let you see. So you can see we have like this where is this soft engine right now. You see I have over, I don't know, 40 textures. I have like sounds you can hear right now. We already have a sound system, but I'm not going to be talking about the sound system in this video. I'm going to be covering that in another video. But we have the sound system, we have these particles and all this stuff going on, but you can see we don't use that much of memory for something like this. And you see the usage of the CPU is actually very low, which means this program kind of, you know, it's optimal, and the memory is not increasing. Even though we're generating particles, we don't have the memory increasing every time. Kind of, you know, that would be weird. That's why it's important to have this lifetime, because if we didn't have the lifetime for the particle, then those particles will get created but never get destroyed, and the memory will be filled and you will have some memory leaks. That's why it's important. Now, in order for us to represent those parameters that I've been talking about, we have like this transform. So if you remember in the previous video, I talked about this transform, but probably you're watching this for the first time and you are only interested in, you know, you're probably only interested in the particle engine. That's why I also want to take a few seconds to show you this transform class. So if I go to object, I have like transform. So the transform only has like the x, the position on the x-axis, the rotation, origin, because I'm actually using this for all kind of object, because the camera class is using this origin for my player to track the position of the player and move the camera. That's why I have this origin right here. Now the scroll ratio is how each object will move on the screen, because all objects in our game right here do have a transform, and you can see they are all not moving with the same ratio. That's why I have this like scroll ratio. I didn't know how to call it. I don't think that name is so nice, but it doesn't matter. We have the shape, so the width and the height. We have the scale, and yeah, we have the renderer flip. So if you want to flip the image vertically or horizontally, that's also important to the transform. This all, it's things that the transform need. And we also have like a texture ID, because all these things impact this texture right here. And I just wanted to show you so that you can see what I mean by transform. So we have this transform which has the position and the size of the texture. And right here we have the lifetime, which is an unsigned integer. We don't want it to be negative anywhere, so that's why we make sure we have it unsigned. It's important. Now since our transform does not have the speed and velocity and all that kind of stuff, we need to define that right here. We have the speed on the x and the y axis. Now to initialize, it's normal. We pass the transform, we pass the speed of the particle and the lifetime the particle is going to need. And yeah, it's important to notice that all these variables are randomly generated. So the position, the speed, so that's we're going to be showing that. But the one who is in charge to generate all that things randomly is the emitter, the particle emitter, the one who is going to be generating those particles. So the lifetime, to define the lifetime, we actually get the current time and we add our lifetime that we've given. Because later when we come and check if this particle is still alive, we're simply going to be checking if the current lifetime, so as you can see right here, we have the is dead right here, this method which gives us the information about the state of the particle. Now this guy right here is important because the engine has this viewport which defines the screen, and we also want to know the current size of the screen, because sometimes it arrives that we resize our screen. So we always want to have the actual size of the screen, because you don't want to have like a viewport which is like this but your screen is actually like this, and you will be generating particles that are going to be living outside of the screen. They will take more time, you're not seeing them, but they will still be alive. That's why we want to have we always want to get this current value of the viewport and kind of use that to check if this particle is still inside of the screen or if he's not over the lifetime. So now to check if the lifetime isn't, if we over the lifetime, we simply get the current time. So what we did here is we get the current time and we put this lifetime on it, and then we come here and we get the current time, which means if we are above the lifetime that was given. So if we are above this get ticks plus lifetime, then that means our lifetime is over. So this particle has to be dead actually. And we also have this here, so we check if the position of the particle with the transform right here is smaller than 0, smaller than y, so greater than the width of the viewport, and and greater than the height of the viewport, then he probably or surely is dead, and we want to destroy that and create another particle. But the one in charge of that is the emitter. So that's basically like your particle class can look out. It's also important to notice that our particles right here are using textures. So this is not like pixels that I'm creating. Those are some small texture that I have, and I'm just using those texture to kind of make this. So since our transform has a texture inside, so we can simply use that texture to be able to render our particle. Now if I switch over to the emitter, so I did call it climate emitter because he's for the rain, for the thunder. I can actually let you see in the night mode. So if you watch the small showcase that I uploaded previously, you probably have seen that we had like this lightning. I just want to kind of let this start, and I'll say lightning. Hope this is gonna work. Okay, just put it like this, and I want to close this. I hope I haven't changed anything on that, because I've been changing some couple of things in that file. So you can see the sky is still, but it doesn't matter. You see, we can also generate lightning. This should be dark mode, but the sky should be dark. Actually, I didn't change the background, that's why, but it doesn't matter. You see, we can also generate lightning, we can generate rain as I've been showing to you, and yeah, generate snow and dust and all that kind of stuff. So, and yeah, let me go back and show you the emitter. So we have this climate emitter. He can generate some climate stuff like raining, snowing, whatever you might want to imagine. or storm. I can also make it, but you know, that's not important. Okay, we have like this constant right here that we've defined. This is the max number of particles that we can create for each climate, for each kind of climate. So I don't know, climate or weather, whatever you might want to call it. So we have for the dust, when we want to have dust, we want to have, you know, 50 particles. That's why you see in the dust we don't have that much going on. You know, we don't have a lot of particles because you don't want to fill the screen with too much dust around, and that's why we kind of make sure we only have 50. And we have for the rain 800, and for the snow 400. Since the snow particles are living a little bit longer than the rain particles, that's why we need, you know, less particle. That's the idea about that. But yeah, it doesn't matter anyway. So now we have the constructor right here, which will be initialized with the kind of particle we want to have: dust, rain, lightning, snowing, and all that kind of stuff. We just pass that. The class destructor, what it simply clear out all our particle in our particle. So I need to show you the member variables. As member variable, we have the current climate. So is it gonna rain or snow or something like that? We have the particle count, which is gonna be defined according to the particle. I'm coming to that. We have like this vector, which has all our particle that we created. So we remember our particle class. And we also have a vector for the texture, because the texture for the raining and snowing and, you know, dusting is different from, you know, they are all different from each other. That's why we need like this vector right here, which is going to be taking the specific particle for the current weather that we have. That's why we need like this vector right here. Now the first function we're going to be talking about is this init particle. The init particle, it's a public method that can be called outside, because we also want to be able to create our own different emitter with different particle types. We don't want to only have one because we have a constructor, and that's why we also want to be able to initialize it from outside with this init particle. That's why we're also calling it here when we pass this variable. Now the first thing is we just set the climate, the current climate, and we clear all our texture and particle vectors. We want to make sure we remove everything. You know, you clean so that you don't get memory problem later, just like that. And now we want to make a switch case. If we have rain, we have these 3 texture IDs. So if you remember, our vector right here is a string. It's a vector with for string with strings. It's because, you know, we have our texture manager in our program, which is taking care of handling texture. So we don't want to play around with texture right here. We simply want to play around with IDs of those textures, and the texture manager will make sure to load the textures and render them on the screen. That's how we made it right here. And now we have rain 1, rain 2. Those are the 3 particles for the rain. And the particle count for the rain, we call our constant up here. So I did want to make it like this because I didn't want to come in the code and change the value of this. Instead, I'll simply do it here and I'll have a different result. So if I put like 5,000, hope that's not going to be too much for my computer, because my computer isn't the strongest one. So I want to make it rain. So you see 5,000, we have like a lot of particle on the screen, and still the computer can handle it, and everything is just fine. You know, we don't have any kind of, you know, it's not slow, it's normal, it's handling it. So let's check our manager and see our task manager, see if things is. So you see we're using more memories right now, but it's pretty much stable. We don't have any kind of, and you see now it's moderate, because yeah, we have like 5,000 particles that we're creating, I would say each 2 seconds, and that's a lot. I mean, less than that, because the life of those particles are between 500 milliseconds and 2 seconds. So it's actually huge. So you can see that's important. Just like that, I can change the number of particles that I want to have, and yeah, then I'll have something according to my desire. And so the same thing is going to be done for the snow and lightning. So that's basically that. And here we have like the update particle. This is where things get really interesting, because you want to, this is where you check if the particle is alive and keep it alive, or kill it, you know, all that kind of stuff. That's why we run through our particle vector or list or array, whatever you might call it. So we check for each particle, is it still alive? If it's not alive anymore, we want to destroy it, we want to delete it, because we want to make sure the memory always get free. So that's why we destroy it right here, and we create directly, we create another one. We just create another one directly. So, and we create another one. If it's still alive, then we want to move it according to what we've implemented. You know, if you remember our move function right here, all it does is take the x and the y position, multiply it by the delta, the velocity and the x and y position, multiply it by the delta time. That's all it does. And yeah, so, and render particle, yeah, this one simply take each particle and call the show function. The show function of the particle right here, simply call the texture manager and draw, and that's it. So we don't need to kind of, you know, do other things right here. So down here we have some important things that are really important. So since we have 3 different types of particle, so we want to kind of have like one function which is taking care of generating according to the current weather. So we have like this new particle method, which simply check the current weather and create the particle which fit to that weather, so to the, or a climate, you want to call it like that. So, and yeah, that's why you see right here, we check, do we actually have, you know, raining or snowing, then we create the particle. And here, down here, we have all our methods to create each kind of particle. We have rain, snow, dust, and thunder. This is actually lightning, I didn't change that. And yeah, how do we generate our random position and speed and velocity? First of all, we want to grab the current viewport of our computer, the current viewport of the screen of our program, because we always want to be inside of that viewport. We want to generate always inside of that viewport. So you can see the x position of this particle is going to be between 0 and the width of the current screen. So like here, for example, we have from here till here. He will never generate a particle outside of that, never. It will always be here inside, and that's really nice because that's important. And yeah, we want to generate the velocity, which is between -1 and 1. We don't want it to be too fast. This is the rain, for example, in the x-axis, because when we have the rain, you know, water drops don't actually move in the horizontal axis that much. That's why we don't have a huge speed in the horizontal axis. But in the y-axis, we do have like huge speed. We want them to move a little fast, and, you know, kind of bring this raining effect. And the lifetime is generating between 800 milliseconds and 2 seconds. So that's actually it. This Randy, as you can see right here, you can see I have a class called helper. So helper right here, it's a class that I create in which I'm going to be implementing the function that can be used anywhere. So the functions that are not classified with a specific task in a specific time kind of class. So I want to be able to use this Randy everywhere. That's why I kind of create this helper class. And you can see it just takes 2 numbers and generate a number between, so which means the max is not included between those 2 numbers. And you know, if the mean is smaller, if the mean is bigger than the max, so if someone gave a weird number right here smaller than the max, then we simply return 0. That's the idea, but that's not the point. We simply, you know, generate those numbers. And now the lifetime also we generate it, and we have our particle constructor that we call right here. We pass the transform, and the transform takes the position on the x-axis. On the y-axis, we want to generate it at 0. That's why it always kind of, you know, start up in the rain. So in the case we have rain, it just starts here by 0. We don't have more than that. So, and here we have like what was this? I don't remember. Let me kind of see this. Yeah, the size of the texture. Now I gave 0 because I already queried the texture size right here in the in the particle, you can see we have this texture manager get instance query texture. So this query texture simply take the value of the width and the height of that texture and put it inside of our transform width and height. So I don't actually need to give a value right here. So that's why I'm putting 0. 0 means do whatever you want, it's gonna be okay. And the texture ID is just what we're gonna be passing up here. So, and the same thing is done for the others. And now you can see right here we also generate the texture randomly, the texture ID we want to have. So we have our texture ID vector, and we generate a number between 0 and the size of the texture vector that we have. Remember, the size, the last number, the number right here is not included, so it's generated between 0 and the size of the texture vector, right, texture ID vector right here, -1. So we'll never go outside of the size of this texture vector. So that's what we generated, and we simply pass it right here by saying, okay, generate the rain particle with the current texture, and that's how we can generate our particle. And when I switch over to my play, this video is getting too long, I need to stop it. And when I switch over here, I just need to kind of create like this emitter right here, and I simply say, okay, climate emitter, and I say lightning, and I just simply go into my loop, and there I can simply say render particles, and I can also say update particles and give the delta time so that I can move the particle around the screen, and the result is what you can see right now on the screen. And yeah, normally I should have the player inside, not outside the raining, but okay, it's because I called the render before I called the player. Now you can see this is how this looks, and this is how this works. Hope you guys learned something from me. If you have, please hit that subscribe button in the description below. If you have any question, if you have any concern or anything you want to know about this, just write me in the comment section below. And yeah, I also want to invite you guys to go out and support my work on Patreon. And yeah, that's all for now. Thank you for watching. Ciao.